The periodic table has metals on this side of the staircase, as we call it, except for hydrogen. Hydrogen is actually a nonmetal, it's just kind of hanging out on this side because it also has one valence electrons like the first group or family. The first group, group 1, is also known as the alkali metals, and they are the most reactive metals. The most reactive metal in the table being cesium. They are so reactive, in fact, that you cannot find them pure in nature. You can't go mining in some mountain somewhere and ever find any of these metals pure. They would always be in a compound. This is also true of the group 2 metals, which are called the alkaline earth metals. These ones are not quite as reactive as group 1, but are still so reactive that you do not find them pure in nature. They will always have already reacted and be in a compound, typically a salt. Groups 3 through 11 are known as the transition metals. They're kind of strange because they have unpaired electrons in a lower principal energy level. As a result, they can form lots of different bonds with lots of different other elements, and also tend to form colored ions in solutions. So if you ever see solutions sitting around in the lab and you walk up and you look at the label, you will likely find copper or maybe even cobalt in the label on that substance. On the other side of the staircase, the only other groups that have names are group 17 and group 18. Group 17 are the halogens. They are the most reactive nonmetals. They're always going to be found in compounds as well in nature, but we can actually make them diatomic. So if we do find them ever pure as the result of some reaction, they would exist diatomically, meaning that they would bond with another atom of themselves. In order to purify any group 1, 2, or 17 elements, you would have to do a process called electrolysis. So typically what we do is we either melt the salt, which would involve really high temperatures, or we dissolve it in water, and then we apply an electric current. And when we do that, we will isolate the metal from the nonmetal in that salt. And that's how we purify any of these substances. You may or may not at this point have seen examples of some of these: magnesium, sodium, I believe potassium and calcium I would show you in class so that you would see how reactive they really are. So you know there are purified examples out there, but they have been purified by electrolysis. The same would be true with any purified samples of group 17.